Hello everyone. So in this video, we will talk about the categorical or the indicator variables in multiple linear regression. So a special case occurs when one or more independent variables or X variables are categorical or indicator or dummy variables. So that is, it doesn't have it doesn't it's not something like kilometers or age or the amount that you put, but it's something like either you have it or don't have it. Okay, it's either 0 or 1. So in a chemical process, for example, in a chemical process, so one variable may be the type of a catalyst that is used in the process, and we may have two different type of catalysts that can be used within the experiment. Okay, so the variable, let's call it the catalyst, will not have any numerical value, but it will be either type A catalyst or type B. That is, it's an indicator or a categorical value. Okay, so how to include this in our model? So let's Y be the process yield, okay, and let X1 be the temperature and X2 be the reaction time for this regression. Okay, so temperature you can just measure it, and reaction time you can just measure it, and Z is the catalyst type. Okay, so it's a binary variable. Okay? It's either 0 or 1. If it is 0, then it means that you are just using a type A catalyst. If it is 1, then you are just using a type B catalyst. Or so for example, if you are just trying to fit Y, which is the price of a car, okay, the price of a car, right? And let X1 be the, I don't know, the kilometer, okay, of the car. And let X2 be the, let's say, for example, the CC, okay, the volume of the engine, okay, volume of the engine. And let Z be either 0 or 1. And 0 means that's manual transmission. It has a manual transmission. Let's say this is MT, okay, MT. And the other one means that it's it has an automated transmission. Okay? So this model can be written as, so yi is equal to beta 0 plus beta 1. It's not xi, okay, remember, it's x1i because this is my first x variable, okay, it's for the ith one. It's the second variable, so this is the temperature of the ith experiment, and this is the reaction time of the ith experiment. Plus zi, again, so you have, for example, Z1, Z2, Z3, that, I don't know. If you have 10 experiments, then that's Z10. Z1, if it is Z1 is 1, it means that you are just using type B for this experiment. If it is 1, it means that you just use type B for the second one. This is 0, which means you are just using 0 for the third experiment. Let's say this is 0 as well. It means you are just using type A for the 10th experiment. So that's okay if you have two variables. Okay, let me just go back. So if you have three categories, okay, if you have three categories, which means if you have three catalysts, then you will need two indicator variables. Okay? So Z is equal to 1, Z1 is equal to 1, and Z2. So you have two Z's, right? Z1 and Z2. Z1, 1, Z2, 0, it means that's for type 1. 0, 1, okay, so Z1 is equal to 0, Z2 equal to 1, it means you're just using a type 2 catalyst. Both of them 0 means you're just using a type 3 catalyst, okay? So, and the model will be something like this. Beta 0 plus beta 1, X1i. So what is this again? This is the temperature of, so for example, what is X1 for? It's the temperature for the fourth experiment. What is X2 for? That's the reaction time of the fourth experiment, okay? So what is Z1 for and what is Z2 for? So for example, if Z14 is 1 and Z24 is 1, it's not the case, sorry, you won't have anything like this. So if this is 1 and if this is 0, it means that you're just using type 1 catalyst in this experiment, okay? So for example, if Z, let's say 1, 7 is equal to 0, and if Z1, not Z1, Z2, 7 is equal to 0, what does it mean? It means that you are just using type 3, okay, type 3 catalyst for which experiment? For experiment or for observation 7, okay? Or let's say if Z1, 17 is equal to 0 and Z2, 17 is equal to 1, it means that you are just using what? If you are just using type 2 catalyst in experiment, in observation, or experiment 17. That's how you just code the categorical variables in your linear regression, okay? So just look at this one. So this is how it behaves, okay? So this is my model, okay? This is your model. Yeah, just look at this one. So this one is the temperature, the reaction time. Now just look at this. Either Z1 is 1 or Z2 is 1. Both of them cannot be 1, okay? Or both of them can be 0, okay? So 0, 0, 1, 0, and 0, 1. If this is 0, 0, the model is beta 0 plus beta 1 x1, beta 2 x2. If this is 1, 0, okay, which is you're just using type 1, then if it is beta 0 plus, since this is 1, right, since this is 1, you will have beta 0 plus beta 3, okay? So if I just make something like this, let's say type 1 catalyst, okay, type 1 catalyst, type 2 catalyst, and type 3 catalyst, okay? And let's try to write, so you have Z1, Z2, and let's say the intercept, okay? The intercept, right? So Z1, Z2, it is 1, 0, 0, 1, and 0, 0. And what is the intercept? If Z1 is 1, it means this is 1. 1 times beta 3, you have a beta 3 here. You will have beta 0 plus beta 3, right? So you will have beta 0 plus beta 3. So in the second line, you have beta 0 plus beta 4, okay? Because now in the second line, you have Z1 is equal to 0, Z21 is equal to 1, then 1 times beta 4 is beta 4, just add it with beta 0, then you will have something like this, okay, beta 0 plus beta. For type 3, you have two Z's, Z1 and Z2, okay? Z1 and Z2, then 0 times beta 3, 0 times beta 4, then you have only beta 0, okay? This is the intercept for type 3 catalyst, okay? And just look at here now. So this is type 3, okay? This is for type 3 because you only have beta 0. This is for type 2, you have beta 4, additional beta 4. This is for what? This is for type 1, right? This is for type 1, you have an additional beta 3. The others are the same, okay? The others are the same, right? The others are the same. So what does it mean? It means that, well, in terms of the change with respect to x1 and x2, all of the regression lines are the same, okay? Because their coefficients are the same. So if x1 increases by 1 unit, then the yield increases by beta 1. Here, beta 1 here, and beta 1 here. It's the same. Similarly, if x2 increases by 1 unit, so the yield increases by beta 2 and beta 2 and beta 2 here. All of them are same. The only difference between these three lines, it's not its slope, it's intercept. Okay, so the intercept here is, right? The intercept here is, it's beta 0 plus beta 3, right? The intercept here, it's beta 0, sorry, plus beta 4. The intercept here is only beta 0, right? That's great. Okay, so in general, right? In general, if you have more than k categories, if you have k categories, then what you will have is you will have k minus 1, what? K minus 1 indicator variance. Okay? Okay, so in general, if you have, again, k categories, then you need, okay, so this is k minus 1, right? So if this is k minus 1. So if you have k categories, then you need k minus 1 categorical variables. You should just encode it with k minus 1 variables. In the next video, we will have an example regarding the categorical variables.